Welcome to It's Good to Be Smart. I'm your host, Dr. Dave Mulder. I love to learn new things, and I hope you do too, because it's good to be smart. Today, we're diving into the fascinating world of chemical reactions, the transformations that explain everything from digesting your breakfast to exploding fireworks to rusting metal. Let's start by imagining a little experiment you might have tried at home. Have you ever poured vinegar over baking soda? Instantly, bubbles start to fizz and foam. But have you ever wondered what's actually happening? Where do those bubbles come from? Well, buckle up, because today we're going to explore how scientists identify chemical reactions and the principles that explain how they work. A chemical reaction happens when substances called reactants interact and form new substances called products. But how can we tell a reaction has occurred? Scientists rely on clues, and these clues often involve your senses. Let's break them down with some examples. Number 1. Temperature change. Have you ever used a hand warmer? Those little packets you shake to keep your fingers toasty use a chemical reaction that releases heat. When the reactants inside mix, they give off energy as heat. This kind of reaction is called exothermic. On the flip side, some reactions absorb heat, like when you mix baking soda with vinegar. Feel the container next time. It gets cooler. Number 2. Color change. Picture this. You're mixing two clear liquids, and suddenly the solution turns bright pink. Magic? Nope, chemistry. Certain reactions involve changes in the arrangement of atoms that can produce new colors. One famous example is rusting. When iron reacts with oxygen in the presence of water, it forms reddish-brown iron oxide. Number 3. Formation of a gas. Remember our vinegar and baking soda investigation? Those bubbles come from carbon dioxide gas. When baking soda, or sodium bicarbonate, reacts with acetic acid in the vinegar, the atoms rearrange to create carbon dioxide, water, and a salt called sodium acetate. The fizzing is a clear sign that a chemical reaction is taking place. Number 4. Formation of a solid. Here's another clue. Have you ever seen a cloudy solid form when you mix two liquids? That's called a precipitate. For example, have you ever seen soap scum left behind in a tub or sink? This might be because you have what's called hard water. Your local water supply has lots of minerals dissolved in it. If you have hard water, the minerals in the water can react with soap to leave behind a filmy white solid. Kind of gross, actually. Precipitates are a great visual clue that a reaction is happening. Now that we know how to spot chemical reactions, let's dig into how they actually work. At the heart of every chemical reaction is one big idea. Atoms are not created or destroyed. Instead, they're rearranged to form new substances. This principle is known as the law of conservation of matter. It can help to think of atoms as kind of like little Lego bricks. If you start with a red brick and a blue brick, you can rearrange them into a tower, but you'll still have the same red and blue bricks. Similarly, in a chemical reaction, the atoms in the reactants rearrange to form the products, but no atoms vanish and none magically appear. Here's an example. When hydrogen gas reacts with oxygen gas, they form water. The reactants are two hydrogen molecules, each of them are H2, and one oxygen molecule, O2. Let's represent this with 4 red Lego bricks and 2 blue bricks. The hydrogen molecules would each be made of 2 red bricks stuck together, and the oxygen molecule would be the 2 blue bricks stuck together. But in the reaction, the bricks get all mixed up, so you wind up with 1 blue brick stuck with 2 red bricks, 2 hydrogens stuck to 1 oxygen. The products of this reaction are 2 molecules of water, H2O. Every atom in the reactants shows up in the products. They're just rearranged. Chemical reactions can also be classified into different types based on how the reactants interact and how the products are formed. Here are some of the most common types. First, synthesis reactions. In a synthesis reaction, 2 or more reactants combine to form a single product. Think of it as building something new. For example, when iron reacts with sulfur, they form iron sulfide. It's like putting pieces together to make a puzzle. Second, decomposition reactions. Decomposition reactions are the opposite of synthesis. A single compound breaks down into two or more simpler substances. A great example is the decomposition of water into hydrogen and oxygen when electricity passes through it. It's like taking apart a Lego tower into its individual bricks. Third, replacement reactions. In a replacement reaction, one element replaces another in a compound. For instance, when zinc is added to hydrochloric acid, the zinc replaces the hydrogen, forming zinc chloride and releasing hydrogen gas. This is like swapping out players on a sports team. Fourth, combustion reactions. Combustion reactions happen when a substance reacts with oxygen to release energy in the form of heat and light. A common example is burning methane and oxygen, which produces carbon dioxide and water. And this is what powers stoves, engines, and even candles. Each type of reaction has its own unique characteristics, but they all involve rearranging atoms to create new substances. Before we wrap up, here are cool, fascinating facts about chemical reactions that might surprise you. Your body is a walking chemistry lab. Every breath you take involves a chemical reaction. Oxygen combines with a type of sugar called glucose in your cells to produce energy and carbon dioxide and water, a process called cellular respiration. Speaking of sugar, when sugar is heated, it undergoes a chemical reaction called caramelization, where the sugar molecules break down and rearrange to form new compounds that give caramel its distinctive golden color and rich flavor. This reaction happens at high temperature, and it's why toasted marshmallows, caramel sauce, and creme brulee all taste so delicious. The glow in glow sticks is a result of a chemical reaction called chemiluminescence. When you snap the stick, two chemicals mix and react, releasing energy as light. Unlike combustion, which produces heat and light, chemiluminescence is cold light. It doesn't produce heat. Holding a glow stick is actually a little science experiment in the palm of your hand. Magnesium, a shiny metal, can burn even underwater. When magnesium reacts with water, it forms magnesium hydroxide and releases hydrogen gas, which fuels a flame. This reaction shows how different metals react uniquely with water, often producing gas or heat as a sign. It's also a spectacular reminder that not all reactions happen in the air. So the next time you see something fizz, change color, or heat up, think about the chemistry behind it. It's not magic, it's science. Thanks for joining me for this episode. Nice work leveling up your brain power today. Remember, smart isn't something you are, it's something we become as we're learning. So keep listening, keep learning, and keep getting smarter every day. It's Good to Be Smart is created and produced by me, Dr. Dave Mulder, with the support of the National Science Foundation through a Robert Noyce educational grant. Subscribe to this feed so you'll never miss an episode, and check out our home on the web, goodtobesmart.com. And until next time, keep asking questions, stay curious, and keep learning, because it's good to be smart.